This question says, a town's population has been increasing at a constant rate. In 2010, the population was 46,020. By 2012, the population had increased to 52,070, and assume this trend continues. First thing we need to do is write a linear function that models the town's population P as a function of the year T, where T is the number of years since the model began. So when it says linear function, right, anytime we're doing a linear model, that means we're using that y equals mx plus b form. That's the linear form of an equation. But instead of y and x, according to what this question says, where our function is modeling p as a function of t, so that's what y is going to become. It's p of t, population based on time. And then that means t is going to replace where the x is. So we're going to have the slope of our function times t plus the y-intercept. That's what b is. So the framework of our function that's representing our situation looks like this. P of t equals blank times time plus blank, where we're going to put our slope in here, and we're going to put our y-intercept into that spot. So now we just need to think, okay, well, in this situation, what is the slope and what is the y-intercept? Remember, slope means rate of change. In other words, if I was to think about what a graph of this scenario looks like, my graph would have time on the x-axis and population based on time on the vertical y-axis. And I know two data points here. I know at year 0, it says that t is the number of years since the model began. So we're going to assume that the model is beginning in the year 2010. So at t at 0, our population right here is 46,020. I'm going to get rid of that comma just so it's a bit easier to read. And then let's say that's year 0. Let's say this is year 1. At year 2, we know that our population has gone up to 52,070. So these are our two data points that we have to go on for our scenario. So our line probably looks something like this, right? This would be the line that fits those two data points. So that's the line that this equation is going to end up describing. Let's figure out what the slope of this line is. Remember, slope is our rate of change. So every time it goes over by a certain amount, how much is it going up? Or since rate of change is usually rise over run, every time it goes up by a certain amount, how much does it have to go over? So if I look at this scenario here, to get from this point to this point, it's going up by, well, it's going up by 52,070 minus 46,020, right? So this upward movement is 52,070 minus 46,020, which is 6,050, right? It's going up 6,050 when it goes over by 2 years. So every 1 year that it changes, it's going up 3,025, if that makes sense, right? Our slope, our rate of change would be 3,025 people for every 1 year, or just 3,025. So that's going to go in here, 3,025. Our y-intercept, remember, y-intercept is just the point 0, comma, what? And if I look here, I see that this line is intercepting our y-axis, or our vertical axis, at 0, comma, 46,020. So that 46,020 is our y-intercept. So our linear function that models this situation says population based on time is equal to 3,025 times t plus 46,020. The slope of that function, right, that 3,025, what it means is each year, the population goes up by 3,025. The y-intercept, what that means, interpret that, it means that in year zero, which was 2010, the population was 46,020. When it asks me to predict the population in 2016, that would be in year 6, because it's 6 years after the beginning of my data set. So all that means I'm going to do is I'm going to say P of 6 is going to be 3,025 times 6 plus 46,020. And then I would just work that out on my calculator real quick. I'm going to say 3,025 times 6 plus 46,020, and it gives me 64,170. So that's the prediction for the population in 2016. And then if I want to know what year it's going to get 75,000 people, I'm just going to set the population equal to 75,000 and solve this equation. So if I subtract 4620 from 75,000, let's see, so I'm subtracting 46,020. That's going to go away. I'll have 28,980 equals 3,025t. So now I'm going to divide that by 3,025, and it gives me an answer of about 9.6. So about 9.6 years later, we're going to hit 7,000 or 75,000. So the year 2010, 9 years later, or 9.5 years later, technically, or 9.6, takes me to the year, not 2016, takes me to the year 2019. So 2019 is the year in which we would get to 75,000